Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Hidayah Farhana Binti. I'll be presenting about my final year project's proposal, which the title is Development and Performance of an Integrated Heat Recovery System for Hydrogen Preheating and Electrical Power Generation. First of all, I would like to introduce my supervisor. My supervisor's name is Professor Madya Dr. Wan Ahmad Najmi bin Wan Muhammad. The topics that will be discussed in this presentation are project summary, introduction or background, literature review, program statement and objective, scope and limitation, methodology, and expected result. This project is about to design a new energy recovery system for fuel cell vehicle FCV, combining the integrated heat recovery system and the technology of thermoelectric generator with hydrogen preheating. Basically, the effectiveness and the performance of the system that has been designed need to be analyzed through experiment and testing method. We move to introduction. Waste heat. Waste heat is produced by fuel combustion or chemical reaction. There are three types of waste heat, which are low-grade waste heat, medium-grade waste heat, and high-grade waste heat. For the low-grade waste heat, the operating temperature is below than 100 degrees Celsius. The example is hydrogen fuel cell vehicle. For medium-grade waste heat, the operating temperature is between 100 degrees Celsius to 400 degrees Celsius. The examples for this type of waste heat are chemicals, food and drinks, and processing industry. For high-grade waste heat, the operating temperature is above than 400 degrees Celsius. The example for this type of waste heat are steel and iron, glass, non-ferrous metal, brick, and ceramic. Fuel cell vehicle system. This system uses hydrogen gas to power the vehicle. The electricity is produced by the combination of the hydrogen and the oxygen. It is also known as electric vehicle (EV). From this system, it has its byproducts, which are heat and water. The advantage of this system is it can reduce the gas emission to the atmosphere so that the global warming can be minimized. The example for these systems are Toyota Mirai and Honda. We move to the integrated heat recovery system. Heat recovery system in this project can be defined as the combination of the technology of thermoelectric generator with the hydrogen preheating. The preheating is to ensure that the temperature of intake fuel is at the optimum temperature. As what we can see in the schematic diagram, there is a blower fan. The blower fan acts like the forced convection. The forced convection is expected to give a better result compared to the normal convection in the heat transfer through the TEG module. Next, let's move to the literature review. Fuel cell. Fuel cell undergoes an electrochemical reaction, which it converts the chemical energy and oxidizing agent into the electrical energy. Fuel cell is proven can increase the efficiency of a system. Also, it can reduce the gas emission to the atmosphere. There are 6 major types of fuel cell, which are proton exchange membrane fuel cell, solid oxide fuel cell, alkaline fuel cell, molten carbonate fuel cell, direct methanol fuel cell, and phosphoric acid fuel cell. In this project, we use the proton exchange membrane fuel cell, PEMFC. For PEMFC, it used semi-permeable membrane. There are 2 sides in this type of fuel cell, which are the anode side and the cathode side. The fuel cell produces heat, water, and air. The advantages of PEMFC are it has lower temperature operation, lighter, and more compact. Furthermore, PEMFC is a technology for low temperature. It is studied that the PEMFC has between 50 degrees Celsius to 100 degrees Celsius of optimal temperature operation, which the new generation, which up to 200 degrees Celsius, is developed for the commercialization. Furthermore, From the previous study, it is stated that the PEMFC has 45% to 60% of energy conversion efficiency. So that it can be observed that PEMFC can reduce the gas emission to the atmosphere and reduce the global warming to the earth. There are two types of PEMFC, which are open-cathode and closed-cathode. In this project, we use the open-cathode type. Open-cathode can be defined as a system that uses the ambient air to provide the cooling. It is also acts as the oxidant. In the previous study, it is proven that the speed of the fan affects the system. It means that the speed of the fan should be minimum to reduce the auxiliary power consumption. Also, the stack of the open cathode need to be heated efficiently to enhance the electrochemical reaction. In the previous study, it is stated that the open cathode PEMFC has between 50 degrees Celsius to 90 degrees Celsius of operating temperature. Let's move to the thermoelectric generator, TEG. First of all, thermoelectric module can be defined as a circuit that generates electricity directly from the heat. TEG is a device that converts the heat flux into the electrical energy through the Seebeck effect. TEG is less bulky and has no moving part. It can be used for the low-grade waste heat. From the previous study, it is stated that the power generation is offered when the temperature gradient across the TEG by the applied heat. It is also stated that TEG can improve the efficiency of energy. Not only that, TEG is also a solution for the ultra low-grade waste heat. TEG can be observed that it can increase the overall efficiency for the fuel cell vehicle system. From another research study, it can be observed that with 8 rows of TEG modules can generate 10.39 watt of electrical power and recover the thermal energy of 1.35 kilowatt with just using of 2 kilowatt of heat input to the system. Next, heat pipe and heat sink. Heat pipe is a passive heat exchanger that enhances the dissipation of heat from the cold side of TEG. Meanwhile, the heat sink is a passive heat exchanger that transfers the dissipated heat away from the TEG. From the previous study, there are advantages when the heat pipe and the heat sink is combined with the TEG, which it can increase the energy efficiency and can improve the performance of TEG. For problem statement, before this, there are several proposed design of waste heat recovery system for the fuel cell vehicle, but those proposed design are not tested physically. So, the proposed design, the new design or system need to be tested physically to obtain the actual performance of the system. So, basically, the objective for these projects are to first develop a test bench based on the new integrated energy recovery design. Second, to analyze the effectiveness of the energy recovery system experimentally. And the third one is to evaluate and propose improvement to the performance of the thermoelectric generator under varying operation condition. The scope of this project is the development of the test bench for the new integrated energy recovery system. Second is to fabricate the new compact integrated energy recovery design. And the limitation of this project is about the instrumentation for the testing and fabrication process, which the instrument that used is at the School of Engineering UiTM Shah Alam. So supposed to be the testing and the fabrication will be conducted at the School of Engineering UiTM Shah Alam. Next, we move to the methodology section. Methodology is a systematic method used to resolve the problem identified through the various techniques. There are two phases of the flow process for this project. The first phase will be started by identifying the problem statement, objective, and the idea generation. After that, it will be proceed to the literature review of writing journal, book, review article or research paper. After that, it will be proceed to the development of the integrated heat recovery system. Then, the test bench will be set up before executing the experiment. After the experiment is conducted, the result will be analyzed, and finally will be proceed to the report writing. Next is second phase. Second phase is about the design of the integrated heat recovery system. The phase will be started by the design specification. After that, it will be proceed to the constructing of the heat exchanger model, and if the design is approved by the supervisor, the design will be moved to the process of analysis. And when the analysis is approved by the supervisor, the design will be fabricated. Next is test bench. Test bench is an experiment method that is used to verify and test a design or model on its correctness or soundness. The type of the test bench that is used in this project is multi-cell TEG test bench. There are 4 parts in this type of test bench, which are heating element, cooling section, test section, and data acquisition. The advantages of this type of test bench are: first, it is easy to fabricate. Second, it is light in weight. And the third one is it is a good insulator for the low temperature application. Let's move to the methodology of fabrication process. Fabrication can be defined as a process of constructing a product by combining the parts using one or more individual processes. In this project, these are the design that need to be fabricated, which are the fins, copper plate for hot side, copper plate for the cold side, tube, heat pipe, and the heat sink. For the expected result, the first one is the new design of the waste heat recovery system is expected to be more effective. The second one is the power requirement of the stack is expected to be increased by the TEG. And the last but not least, for the expected result is at least 8% of the utilization of the waste heat recovery system can be achieved. That's all from me for my final year project's proposal. Thank you.